Taking into consideration the correspondence of Pascal and Fermat that we discussed previously, on this video we concentrate on the next step that historically has made the probability theory evolve and come to existence. We are talking about the book of Huygens, The Value of All Chances in Games of Fortune. The book was published in 1657, 3 years after the work of Pascal and Fermat, where they were trying to solve the problem of points. In this book, Christian Huygens takes over their work and formalizes what at the time was only supposed about. It is considered one of the first books on calculus probability, formulating the propositions that represent the foundation of probability theory today. Its first version was written in Dutch, but what we have access to today is the English version written around 80 years after. It starts by saying that even though in games of fortune, who is going to win the game is an uncertain outcome, still we can determine the likeliness of success. This may be considered an eureka moment when it comes to the statistics and the evolution of thought of humanity on fortune, luck, and randomness. It was in this moment that we started to talk about the value of expectation. How? Well, inspired by earlier works that were done until then on studying the games of fortune, Huygens formulated the mathematical propositions that form the very foundation of probability. The first proposition introduced the concept of average to future and non-physical data. He determined that the fair price to a fair game would be the mean of the points somebody could win. Now, in gambling, we call a fair game when a game where if there are two players, then both have equal chance of winning the game. The determination of the fair price to pay, on the other hand, is a little bit more complicated. Huygens took on the work of Pascal and Fermat and did something wonderful. He tried to determine this price through mathematical thinking. He started to consider a game of two people where you can either win $3 or $7. The question is, how much do I need to pay to enter this game for me to feel like I am not being fooled? Which is the fair price for this game then? Until this point in history, the average was considered in everyday life as an intuitive measure of past data and physical things, like for example the average weight of 3 rocks. This was the moment we started to think of the average as a measure of future possibilities. Huygens defined the fair price of our game by arguing that it is only fair if you can take that situation and recreate it with a clear 50-50 chance of winning. So he said that if we consider that both players put on the pot X amount of money, then they contributed at the same measure to the game. Now, if we throw a coin, one of the players will win the whole pot. But the rule is that the winner should pay the loser $8. So, if we do the math, we would have 2x minus a equals b, where a is the money that the loser gets and b is the money that the winner gets. In our case, it would be 2x minus 3 equals 7. Solving this equation would give us the fair price, which would be x equals 7 plus 3 divided by 2 equals $5. This was called the value expected. It is what today we consider as the arithmetic mean. This was a revolutionary way to think about the arithmetic mean. He turned the mean into the expected value. He proved that the mean isn't just a description of the past. It is also the way we value the future. It's a possible way to value the future. In the second proposition, Huygens extended this concept to 3 equally probable outcomes, A, B, and C, meaning that we have 3 players with equal chance of winning. To calculate the expected value in this situation, he recreated the hypothetical bet that we talked about until now. He said that if 3 players bet X value of dollars to win A, B, or C, In order for the bet to be fair, then x will be equal to a plus b plus c divided by 3, and proved it by showing that the way for the players to feel like they were playing a fair game was if they could recreate it by adding at the pot the same value, and that value would be equal to x. Now, in the first two propositions, he established what the future outcome of the game would be if every outcome could be equally likely. Now, in the third proposition, he started to consider what would happen if the game was tilted. So, we have a situation where a player is more advantaged than the other. To find the just price for this lopsided expectation, Huygens doesn't just guess. He invites more people to the table to turn an unequal chance into a perfectly balanced game. He tries to recreate the game using what he already knows. He recreated the game by considering a situation where everyone has a 50-50 chance. So we have a room full of players, and we consider players of type A and players of type B. Now, let's say that you participate as well as a type A player and make a deal with the other players. All contribute X to the pot. If the player A win, they pay you $8. If players B win, they pay you B dollars. So, if you win, you take all the pot and pay the players respectively A and B. So the situation would be A plus B times X minus A minus 1. Remember that it is A players of type A minus you that are also a type A player. So we have A minus 1 times A plus B times B equals A. And X equals A times A plus B times B divided by A plus B. This is the birth of the mathematical expectation for unequal probabilities. This is the one of most advanced and crucial rules for complex lotteries and bets that we still play today. Huygens applied these foundational results to solve the problem of points and to calculate the fair distribution of stakes in interrupted games. He also used these results to analyze the various gambling games that were popular in his era. Notably, this mathematical framework that he developed provided the tools necessary to prove that the Genoese lottery, which was a famous gambling tournament of the 17th century, was rigged. We will explore how these results expose these unfair odds in our next video.